Does anyone have any questions for me so far? Homework questions? Anyone have any questions for me? And I do have to end the Zoom to that one.
I have a question from the last homework.
Mm-hmm. What section is it? Is that 6.4, 6.5, or 6.6? Can you type on the chat room or talk to me, Cameron? Hmm? Which one you have questions on, Cameron?
Yeah, one sec. Let me find it. I think it's 6.4.
6.4. Okay. Anyone else? Either you talk to me or type in the chat room so I can then I can help you with your homework. And you guys can see my screen, right? So only one homework section due tonight, which will be 6.4. 6.5 and 6.6 is due on next Wednesday, and we just have like a few more little questions left in 6.5, and then I will talk about 6.6, the inverse trigonometric function in this case, and then these two will be due on Wednesday. Okay, so let's talk about 6.4. Anyone have any, beside Cameron is looking for the questions that he needs help. Anyone have any questions on 6.4?
So for question 14, it says
1.4.
like when you're like when you want to find the endpoints, like the starting point and the endpoint, it says to put it in interval notation. And I'm kind of confused on what they mean by that.
Yep. So remember last time when when you start the starting point and the end point, right? And we always use a bx minus c, right? And because this is a sine or cosine function, we start at 0 and we ends in 2 pi. So if you want to put this in an interval notation, let's say you solve for x. So when you solve for x in this case, let's say your x is pi over 2, for example. Okay. And when you solve for x for the endpoint, let's say it is 5 pi over 2, example. And then if you want to write this in an interval notation, you just put them in parentheses. So parentheses pi over 2 to 5 pi over 2. So you start at 5 pi over 2, you end at 5 pi over 2. So this is how you write this in the parenthesis case. You all right there, Cameron?
Okay, thank you.
Yep. So this is how you just find your like example, like this question that we have here is no matter which one you do, the bx minus c is pi x. So your starting point in this case will be pi x equals to 0. And then your endpoint in this case will be pi x equals to 2 pi. Again, we use 0 to 2 pi is because that is your one cycle for sine. It starts at 0 and ends in 2 pi. So we just solve for x here. So I divide both sides by pi. So x in this case is 0. And then I divide by pi for the endpoint, solving for x. And the pi will cancel. So x in this case is 2. So if you want to write this in an interval notation, means it starts from 0 and it ends at 2. So this is how the way that they want you to write. So beside doing this, anyone have any questions? Cameron, is that your question or no?
No, my question was, so for number 23 and 24, like I understood how to do the first part. It's just writing, I think, like g in terms of x. I didn't know how to do.
Okay, very good. And again, this is not gonna be a part of your the last part. This part that you have here is not gonna be in your test, so you do not need to worry about writing g of x into f of x. So what does that mean if like question number 24 or 23 or 24, part D, when they say write the g in terms of f, as what we know is if you look at this function, it's already telling us that your f of x is sine x. Okay, it's given us f of x is sine x. And then the question for this question 23, g of x in this case is given us by sine 5x plus pi. So what happens is if you want to write g of x in terms of f of x, now we know that f of x in this case is sine x. So in this case, your sine x is going to be replaced by f of x. So how do we write this is f, and then because your x here has, your inside has 5x plus pi, so you just need to replace this by 5x plus pi. So this is how we write g of x in terms of f of x is because what you do here is you just take out your sine and replace it with f, and then anything that is not sine, like the 5x plus pi or anything that in front or something else, you just replace it. So this is how you write the g of x in terms of f of x. So it'll be 5x plus pi in this case. Okay. Again, this is not going to be asked in your test. Again, I just want to tell you so you don't have to worry about, same thing with 24. 24 is also given us the same type. The f of x in this case is sine of x. So g of x in this case is 4 sine 2x minus pi minus 5. So if you want to parentheses, if you want to write the question D, how you write g of x in terms of sine of x, f of x. So what you do in this case is you just replace this sine to become f, because the sine f of x is sine x. So your answer in this case will be 4 f 2x minus pi minus 5. So you just this is, so it's as easy as that. So so this is how you write g of x in terms of f of x, is you just take the sine or cosine, if you have cosine, to turn it to become f in this case. So your answer in this case will be 4 in front, and then multiply it with what we have here, 2x minus pi in the parentheses, and what we have outside, minus 5 outside. Oh, this is plus, so because it has a minus, so that means you need to put a negative 5 inside here. You guys all right here? Okay. Again, don't worry about this writing g of x in terms of f. So in other words, means that you just need to change your sign to become f. That's what it means in this case. Anyone have any more questions for me? Anyone have any questions for me? So this is 6.4 homework. So I'm gonna save this. So if you do have any, if you need to refer back after class, you may. Let me save this. Yeah, I'm in school today, so it might be a yeah. So because I have a test, I'm gonna give a test today in one of my class. So all right. So we're gonna do the new one. We're gonna continue with. Anyone have any more questions before we continue with our note 6.5 here? So I teach you guys how to draw the tangent graph. So make sure you need to know your tangent graph. I also teach you how to draw the cotangent graph. In order for you to draw the secant and cosecant graph, secant, you need to draw the cosine graph first, and then you have to do your asymptotes, your horizontal and your vertical. And then after that, you kind of do a reflections on it. So make sure you know that if you got a hill, that it will be a valley. If you have a valley, you got a hill. Same thing with number 4 here. This is where we stop on Monday. This is a cosecant graph. So we will need to draw a sine graph because that is the reciprocal of cosecant. So in this case, you need to draw the sine graph of this. And again, because we are drawing sine graph or cosecant graph, you do need that 5 points. So that's why when you look at this, for sine and cosecant or secant and cosine graph, you need the 5 points that we're talking about. But when you do your tangent and cotangent graph, you do not need the 5 points that we mentioned. Okay, so so for this case, what we do here is you need to, as usual, if you draw the sine and cosine or tangent or cotangent or secant and cosecant, you need to tell me what is your A, your B, your C, and your D. That's always the first thing you do. So go ahead and look at this question number 4 that we have here, which is this one that I've written down. Tell me what is your A, B, C, D here.
A is 1.
A is 1. That's the first number. Okay. B,
2.
2. Yep. That's right next to your X, like slope. C.
Hi.
Yes, very good. Faris, is it Faris or?
Oh,
who's
she
that?
said C. She said C. The girl.
The girl.
Better.
So yeah, pi is correct. It's not negative pi. It's because originally this is negative, a minus sign in the middle. So make sure you know you switch them. Pi is correct. And D.
There is no D.
There's no D, or in this case 0. Okay. So when I say no D means it's 0. Okay. So what will be your amplitude in this case?
1.
1. Since your A is 1, so amplitude is the absolute value of A, so that's 1. Sine the period is 2 pi over B. So in this case, since your B is 2, so what is your period in this case?
Just pi.
Just pi, yep. And phase shift, the formula is C over B. So in this case, the C is pi and the B is 2. So your phase shift in this case is pi over 2. And what is phase shift means? If it's a positive, means you go to the right pi over 2. That means if you have a sine graph, you just need to move the sine graph to the right pi over 2. So you look something like this, the blue one. So everything is shifted pi over 2 to your right. Okay, so that is the meaning of phase shift. Okay, just to tell you what's going on. All right, so this is your, and then we don't have a D, so that's good. So sine, does anyone remember what is the 5 original points for sine? So start with this point. So there are 5 points that is important.
0, 0.
0, 0 is one of the, there's a beginning point. And then start with, then after go with what?
Pi over 2, 1.
Yep, will be pi over 2, 1. Sorry, my. So that will be the correct one. And then what is the next one?
Pi and 0.
Pi 0. And then followed by
3 pi over 2.
over 2. And since we go down here, means it is what?
Negative 1.
Negative 1. And then we go back to 2 pi. What you get in 2 pi?
0.
0. Yep. So that is your original point. So what we do here is like just now, someone asked me the starting and ending point. So the starting and ending point is where you take your bx minus c equals to 0 because you start at 0 and it ends at 2 pi. So what is your bx minus c in this case? What is a bx minus c in this case? Everything inside your
Parentheses, yeah.
parentheses.
Yeah, that's what I thought.
So what is the bx minus c if you look at your question here?
2x minus pi.
Yep. So you take 2x minus pi. equals to 0. That's where you start at 0. And you take 2x minus pi equals to 2 pi. This is where you end. So again, solve for x here for both cases, then you know where it starts and where it ends. So anyone know where it starts at? Move the pi over and then divide it by 2. What you get? This will be at, starts at pi over 2. And move the pi over, so you add pi. And then you have to divide this by 2 because you have the 2 here. So what is the ending part here? It will be 3 pi over 2 because 2 plus 1 pi is 3 pi over 2. So that means it tells us that the starting point in this case is pi over 2. And the ending point in this case is 3 pi over 2. So what you need to do next is you have to figure out what do we need to add so that you will get the same points. So since we got 4 quadrants, so what you do is you take the period divided by 4. And the period that you calculate early on is pi. So in this case, it's pi over 4. The reason why it's over 4 is because you got 4 quadrants. So what you do here is you have to add pi over 4. Keep on adding pi over 4, so you will get all your x value. So what is pi half plus pi 4? So it's a half plus a quarter. So if you ignore the pi, this is 1/2 and this is 1/4. So you get what? No room to squeeze it. So you will get 3 pi over 4. So don't forget, this is like you add a quarter. So half plus a quarter is 3/4. And then 3/4, if you add another half, you get just 1, exactly 1. So pi in this case. And then you add another a quarter. So you will get 5 pi over 4. And then you add another quarter. So 1/4 become 1/2. So that's why you get the sequence here. So this is how you figure out your x value. So make sure you guys know how to do this because again, I asked you in your first test.
Do you always divide the period by 4?
I'm sorry?
Do you always divide the period by 4?
Yeah, to figure out because you got 4 quadrants.
Okay.
So now my question is, how do you find your y value? Because the x value is doing this, taking your starting point, ending point, and then take the period by 4 and keep adding. So how do you figure out your y value in this case? It depends on what? Your A and your D, okay? Make sure you know that you always multiply the A, you add the D or subtract the D, depends on what you have. Since we don't have a D and the A is 1, so you just multiply your y value by 1. But you know, guys know that if you multiply anything with 1, you get back the same thing. So for this case, if you multiply this with 1, 0 times 1, you still get 0. This one you still get 1 because 1 times 1 is 1. This one you will get 0. This one you will get -1. And this one you will get 0. So that means you just get back the original y value because you only multiply by 1. So all these final 5 coordinate points that I have, you graph it. Now, again, you have to be careful with this is because you keep on adding pi over 4 here, right? So when you guys do your graph, you have to follow not the first point, you have to follow this what we call as the period over by 4. That means that every single units here is not half, it's not pi over 2, it's actually pi over 4. So your pi over 2 naturally is going to be over here. So some of you were asking me which one determines your your units on the x-axis is the p over 4. So whatever you did in p over 4 is this pi 4, then the unit here has to be pi 4. I mean, one of this has to be pi 4. So this is the one that determine it. So watch carefully. Sometimes you need to think about it, because when you add the pi 4, the 3 pi over 4 is actually the one next to it. And then pi will be the following coming up. And then 5 pi over 4 is the next one. And then 3 pi over 2 will be this one. I'm going to write it on top because I don't have room for squeezing everything in there. So you're using 1, 2, 3, 4, 5 here. And the highest y value is 1 and the lowest y value is -1. So now we begin to plot this sine wave. So pi over 2, 0 is right here. 3 pi over 4, 1 is right here. Oops. And then pi 0 is right here. 5 pi over 4, -1 is right here. And then 3 pi over 2 is right here. So you guys got this sine wave, which is a hill and a valley. And you can tell that it's been moved to the right pi over 2. That's why you start at pi over 2. And if you look at from this to this, that is your period, which in this case will be pi. So if you take 3 pi over 2, take away pi over 2, so the whole period is pi in this case. So this is your sine wave. However, your question did not ask for sine wave. Your question is asked for what? Cosecant. So you still need to draw. Oh, I'm going to draw a few more sine wave here. So this fellow will look something like this. Because it takes 2 units to go one, like half a cycle. So this will be -pi over 2. And then you take 2 to make a little hill, and then you take 2 to make a valley. So this is your sine wave in this case.
I have a question. So I forgot, but how do you decide like how far to put each number from each other, like pi over 2 and then 3 pi over 4 and then pi and then 5 pi
It's
over
right
4?
over here for your final points. And then the period, the p over 4 that you calculate here is to determine how far is each one of this.
The period. Okay.
Yeah, this one that you calculate.
Yeah.
That is the one that kind of figure out. So since we're moving a quarter, so that means this all has to be a quarter apart.
Yeah.
So you have to kind of like I will recommend you to don't draw the y-axis first, draw the put out the point first, and then after that figure out where's your y-axis by looking at your period over 4. That would be something I would recommend. So once you get your sine wave, we need to draw the cosecant graph. So you need to draw your horizontal and your vertical asymptote. Since this is at 1, so the horizontal asymptote will be at 1, and also at -1, because this is where your the highest and the lowest range in this case. So in order for us to figure out your vertical asymptote, do not forget, this is very important. So a lot of students get this wrong. In order for you to find your vertical asymptote is where you follow your d sign. So since you say d is nothing, or in this case 0, right? Nothing means 0. So that means that when your your y value is 0, that is your vertical asymptote. So your vertical asymptote in this case is on here. This is where the y value, your y value is 0. It will be at pi over 2. So it's going to be at 0, pi over 2, pi. So this is your vertical asymptote in this case. So make sure you guys know that the d that you figure out here is to determine where you draw your line, your vertical asymptote line. And also that when you draw your vertical asymptote line, make sure you also look at that you get the whole valley and the whole hill, not partial each of them. So like this one, you get the whole valley, a whole hill, and this one you get the whole valley. So this is the correct vertical asymptote in this case. So don't draw a vertical asymptote like right in the middle like this. This, if you draw the vertical right in the middle like this, that is wrong. Okay, so don't do that. Okay, so make sure you draw the one that is give you the whole value here. So your cosecant graph is just a reflections of it. So I'm going to draw this in pink. So this is going up. So this will goes. This is going open downwards. You open upwards. This is open. So you just kind of reflecting on each side of it. So the pink graph that I draw here is your question for the cosecant graph in this case. Anyone have any questions?
The
Yep.
spaces, like the reflections, like you see how you didn't miss out on those spaces. The last time we drew in them, like I remember. Wait, let me look at the notes. Like, does that mean like? How do I explain it? Like last time you did all you covered the whole thing on the row, like you did the full row going up, and you didn't leave any spaces.
What do you mean by I don't leave any spaces? Oh, no. The reason why I goes out is because if you have a negative, then you reflect the whole thing.
So, you change it if it's a negative?
Yes, if you have a negative in front here, then this pink graph that you draw, it has to be flipped around on the x-axis.
Oh.
So this fellow will goes down, and then this fellow will goes up. So if you have a negative in front.
Oh, okay then.
But we don't have a negative. So and usually I need 2 cycles. And so how many if I need 2 cycles, means I need at least 2 that goes going upward and 2 that goes downward. So if you draw at least 2 of these that go up and 2 of these go down, then you get yourself a 2 cycles. Yep. So it only happens when you go that way is when I have a negative in front. So either you have this one or you have the one next to it. The one next to it is when you have a negative in front. And usually it will be detected if you do it. So you don't need to worry about Sundus, you don't need to worry about that case, because your A will be negative and then all your sign here will be switched around. So you don't need to worry about. So this will take care of all those issues that you're asking for. So my question to you guys is, looking at this pink graph, what is your domain and what is your range? So this one starts at where? It starts at pi over 2, right? So what is the domain in this case? So you start at pi over 2. So your domain will be pi over 2 plus
pi.
K pi, because your period, right? Your period is another part that figure out domain. Now, put a K next to it. But if you do sine, cosine, tangent, cotangent, yes, that is correct. But if you're doing secant and cosecant, then make sure that you have to make this over 2. The reason why is because when you just do K pi, you're doing the whole cycle. But as you know that we got asymptotes on either end. So this pi cycle, the whole period that we have, is actually cut into 2. Okay, so that's the reason why that when you guys do secant and cosecant, what you need to do is you take the period. This is for secant or cosecant graph. You need to take the period divided by 2 and put a K next to it. Okay, so this is how you figure out your what you add on. But if you just do sine, cosine, the rest of it, sine, cosine, tangent, cotangent, then you just do K times P, whatever period you have found here. Okay, so that is your domain in this case. So does anyone know what's your range in this case? It goes from negative infinity all the way till -1, and it's included means you touch at -1, and then it jumps from -1 to 1 to infinity. So this is your range in this case. So make sure you guys know how to figure out this domain range and how you graph this. This is really important because in your test, this was like 11, 12 points because you have to do, see, you're doing the whole thing, right? The whole page of stuff. I do recommend you to practice is because when you practice on your own, because when you do your online homework for this section and 6.4, all your graph is multiple choice, and some of you not even doing any work, you just simply ABCD it, right? Oh, this is C. Oh, correct, good. And guess what? In your test, you won't get multiple choice. You have to do all this work that I just did over here for you. So make sure you guys know what to do here. So what is the best way to practice this is, let's say I'll show you your online homework. See, this is what your online homework does. This is the question and you just pick A, B, C, D, right? Oh, I just think it's A, I think it's B, you know. What is the best way to do is just treat this question like a test question, means it's not given you open-ended, and you're gonna do all this work that I just did here, and then you draw it out, and then you just come. Then after that, this is what I suggest you to do in your homework or in your test, instead of some of you just simply putting, oh, it's A or it's B or C, something else. Some of you just guess about it. Okay, so do not do that. It's not gonna help you in your test, I can tell you that. Right. Anyone have any questions for me? We have a little bit left on 6.5, which will be how do we solve this equation? So we're not using the graph. What we use here is we're gonna use the unit circle. Okay, so the unit circle is actually always quicker. Some of you ask me which is quicker, the graph or the table or the unit circle. I will tell you straight away the unit circle is the fastest way to do it. Okay, so don't use the graph or the table. So this is number 5 here, is asking us for cotangent x is equals to -√3/3. So you need to figure out x in this case. Don't forget x is your angle, and you need this in the interval of -2 pi and 2 pi. So that means that if you look at your circles, that means that it goes from positive from 0 to 2 pi. So you're gonna go one full cycle, and also it goes counterclockwise, -2 pi. So that means that your answer in this case will consist of 2 positive, because from 0 to 2 pi you got 2, quadrant 1, 2, 3, 4. Don't forget, this is all students take calculus, so make sure you know that. Like cotangent, can someone tell me cotangent is negative in what quadrant? Anyone know what cotangent negative is at? What quadrant?
Is it 3rd and 4th?
No, third is tangent is positive. So don't forget tangent and cotangent is the same. So what is 4th is, so S and C. So you're looking for S and C. So in this case, it'll be quadrant 2 and quadrant 4. So you will get 2 answers that is positive in quadrant 2, 4, and you got 2 answers that is negative because you go clockwise, the purple one. So that means you will have 4 answers in this case. 2 of them is the positive one, and 2 of them is negative. So how do you figure this? What is the value for it? So you do the tangent, because yeah, let's do tangent, because then you get used. Yeah, that I should use tangent in this case. So what we do in tangent in this case is I will flip this, right? Cotangent is that, tangent you flip it. So it's gonna be 3/√3. So I will rationalize this, means I multiply this by √3. So this will become -3√3/3. So this 3 will cancel, So what we get is -√3. I just put it over 1. The reason why I do that is because if you use the unit circle, tangent in this case is what over what? Tangent in this case is y over x. So that means that this should be your y value, and this should be your x value. So can someone tell me by looking at your unit circle here, what y value give us -√3 and your x value is 1? A square, yeah, negative square. Now, because if you look at this, they all have over 2, right? See that they all have over 2 next to it. So what do? Is we just add them over 2 to it, because the 2 will cancel out. So this will be something that, so if you got something like this, you just make it over 2, because they all have 2 over 2 next to it. Because when you divide, the 2 will cancel each other out. So which one of these will give us the y value is -√3/2?
5 pi over 6.
5 pi over 6.
And I can't see.
Oh, sorry, yeah.
Oh, and then 11 pi over 6.
So 5 pi over 6. That will be wrong, because that's your x value is this fellow. I'm talking about y value.
Then 2 pi over 3.
Then it'll be 2 pi over 3. Okay. And don't forget the negative. This negative, you can move it where? Up and down, doesn't matter. So your answer in this case will be so will be this one, 2 pi over 3. So x in this case will be 2 pi over 3, which one also will give us, this is in quadrant 2. This is in quadrant 2. And the other one should be in quadrant 4, which is right over here. So which one will give us a negative √3/2 and 1/2? One of them is negative, one of them is positive. So which one is that?
5 pi over 3.
Will be 5 pi over 3. So that will be in quadrant 4. Now this answer is only works from 0 to 2 pi. But since so that means it goes the counterclockwise. So this answer also needs you to give us the negative, the one that go clockwise. So how do we find the negative one? Is we just add 2 pi. You just subtract 2 pi. Remember, when you have, like, let's say you got 120 here, and if you want to find the other one, we just subtract 360, right? To find what is the negative one. So this one, because it's in radian, so in order for us to find the negative one, we just subtract 2 pi for each case. So what you do in your calculator is you take 2 over 3, subtract 2. And you will get your negative answer. So anyone have an answer here? This will be both of them will be negative. So when you subtract from 2 pi, this is -4 pi over 3. And when you take 5 over 3, subtract 2, you will get -pi over 3. So this will give us -4 over 3. And this will give you -1/3. So this will be your answer for this case. Tough? So make sure you know how to figure out this is what we call as inverse trigonometric function, which you will learn in the coming section 6.6. Let's do one more. Number 6 is given as cosecant x is √2. So anyone know what to do with this kind of question? Yep, this is correct. Do the sign first. because you do the reciprocal first. Every time when you have a cotangent, cosecant, or secant, do the reciprocal first. So sine x in this case is what? Anyone? Flip it. Anyone know what's the flip of this?
1 over square root of 2.
Make sure you rationalize this. What's the rationalize of this? This will be
Square root of 2 over 2.
over 2 over 2. So sine, can you tell me, looking at this picture, this is positive, right? Because this number is positive, right? So can you tell me what quadrant it has to be when sine is positive? Forget, this means what? Everything is positive, so that means should be in quadrant 1 and also in quadrant what?
2.
2, yep, because sine is positive in quadrant 2. So sine, if you look at your unit circle, is that x or y value? It is the y value. So can someone tell me, looking at this unit circle, the y value has to be the same as square root of 2 over 2? Anyone? Which one of these give us square root of 2 over 2 for the y value? In radian form? This one,
3
right?
pi over 4.
So it will be 3 pi over 4 and also what? Pi over 4. And don't forget, pi over 4 is quadrant 1, and then 3 pi over 4 is quadrant 2. So your answer in this case will be pi over 4 and 3 pi over 4. This is 1 and 2. But again, this is only work from 0 to 2 pi, the positive one. So how do you find the negative one? Like last time, what do? We subtract 2 pi. So can someone tell me what happens when you take 1/4 minus 2? What do you get? Go ahead, pi next.
Negative 7 over 4.
No. The 1/4 is positive. They are negative for sure. You guys have calculator, right? This will be 5 pi over negative 5 pi over 4. This will give us negative. Is that no? Oh no, you are right. Someone said, is that Adrian saying something? Sorry, you are correct.
Yeah.
It's not 5, it's 7. You are correct. My bad. It should be 7 over. You are correct. I am sorry. You are correct. This is negative 7/4. And then you take 3/4, subtract 2. What do you get? This will be 5 over 4, right? So, yep, that's 5 over 4. Yep. So this will be your answer for this case. So I would really suggest this kind of question also will come up in your test, but I won't ask you for the negative one. I will only, in the test, I will only ask you for the positive one. So you do not need to worry about subtracting 2 pi. So this is the one that I will asking you in the test. So make sure you guys practice this. This is something, how do you practice this? Is you just look at your unit circle, or you can do your homework. Yep, I think your homework has some of those. You just figure out a number here, any number you want, or you can divide the number. So you can take like negative square of 3 over 2, and you just say tangent, not tangent, you can say sine or cosine of it. Then you can figure out what's going on. The other way you can practice this is looking at your ebook. Okay, so if you go to your ebook, so that's another way for you to do is, some of you asked me about this. Remember, I don't know how many are asking me this. So if you guys want to practice, if you did your homework and you say, you know what, I need practice more, this is the one that I really want you, if you're going to practice more, then practice here. It's coming from your book or your ebook. If you have a book, look at your book, page 477, practice though. And some of those questions have exactly the same like this. So like 49 to 56, I think is something like this one. So I would recommend you guys to practice on it. Okay, so that's how you practice if you need. And on the odd ones, the answer is at the back. So if you want to do the odd ones like 49, 51, you can do those because that will be a good practice for your for you. So this is usually how I want you guys to practice. So you will get all the benefits of it. Okay. So this is the end of 6.5. Anyone have any questions for me on 6.5 here? I'm going to take attendance now. So go ahead and, type presence in your chat room. Yep. And we'll continue with 6.6, the inverse trig function. So let me give you what is the definitions of the inverse function. So the definitions of inverse function has two. It has to be function, means function means it has to be one-to-one, we call it. It has to be one-to-one. Okay. What does it mean by one-to-one? Means you have one x value, and when you plug it into the equation, you only get one y value. This is the meaning of if we have an inverse function, we call it as one-to-one. If you're talking about graphing, that means it has to pass the vertical line test, and it also has to pass the horizontal line test. So this is the meaning of inverse function, means it has to be a one-to-one, and it has all. If you talk about graphing, then it has to be passing both vertical and horizontal. Vertical means vertical line like this, and horizontal means like this. When I say pass, means that when you draw a vertical line and a horizontal line, it can only cross at one point. Okay, so for example, is if you look at a parabola, which is an x square, this x square doesn't have an inverse function. The reason why it does not have an inverse function is because when you draw a horizontal line test, it doesn't cross at one point. It crosses at 2 points. Okay. However, we know x squared has an inverse function, which is the square root, we call it. So we call it inverse. Mohammed, I should send you an email. If you have a question, Mohammed, please I recommend you to ask it from the web assign. So don't send an email to me. If you do, send me the work. Yep. So Mohammed, if you want to send me if you have questions, send me the work in my email, and then but ask it in the web assign. So what we do is, because we know x squared has an inverse function square root, but it does not pass the horizontal line test. So what we do in this case is we do what we call as a domain restriction. So what is the meaning when I say domain restriction? It means that instead of taking the whole parabola, I will just restrict this domain into half of it. So if I take half of this parabola, then this will have an inverse function. This will have an inverse function. So when you domain restrict it to become x is greater than or equal to 0, means you take the positive side, then the x squared will have the square of x will be the inverse function in this case. Okay. However, we can also instead of taking the right side, we can also take the left side. So if you take the left side, then the domain restriction will be on the left side. Then the x squared will also have an inverse function, and that inverse function is going to be negative square of x. So usually we do the right one, the positive one. Really rarely we take the negative one. So but the main thing is that although if you fail the horizontal line test, we can still make it as a function as long as we restrict the domain, means that we take a part of it. Okay, so this is what happens to the definitions of inverse function that you guys need to know, because that will apply to the sine, cosine, and tangent. So let's talk about sine in this case. Now we know the sine graph is the valley and the mountain and the valley, right? This is the sine wave, and it goes from 0 to 2 pi. So what happened is, if you look at the horizontal, it definitely failed the horizontal line test because it passed a lot of points, not just one. So what do we do here is we will do what we call as a domain restriction. So we will restrict the domain so that it will pass the horizontal line test. So what do we do to restrict? Means we need to erase this whole, so we're not going to concentrate on the whole sine wave. So we just only concentrate on a part of it. So where do we concentrate on so that it will pass it? We concentrate on this red box here. So this is a red box that we concentrate, means that we're going to erase the whole sine wave and we just only concentrate on him. Now, if you concentrate on just that piece, then what happened is that it will pass the horizontal line test, because when you draw the horizontal line, it only intercept one point. And when you draw the vertical line, you also intercept. So you pass both the vertical and horizontal line test. So what happened in this case is we will restrict the domain from negative pi over 2 to pi over 2. So this is a domain restriction that we have. So if you restrict and the value is still from 1 till negative 1. So the range is still from 1 to negative 1. So if you restrict this domain to negative pi over 2 to pi over 2, then we will have what we call as a inverse function. And the inverse function for sine is a sine minus 1x. This is the inverse function for sine. Okay. So this is very important. So you need to know this. And another properties of definitions of inverse function is your domain of the function is the same as the range of the inverse function. And your range of the function is the same as your domain of the inverse function. So that is the proper one of the, so that means they flip-flop. So as you guys know that if you look at this sine, this restriction domain, so this, let's say this is your f of x here. So the domain for this, since we restrict it from negative pi over 2 to pi over 2, so your domain in this case is not all real numbers. It used to be all real numbers for sine, so we're going to restrict it to this fellow. So from negative pi over 2 to pi over 2. And your range, the highest point, the lowest point is negative 1, and the highest point is 1. So this is the sine function if you restrict the domain. So what happens to the inverse function of sine? It switch around. So that means that your domain for this inverse function is the same as the range of the original function, which will be negative 1 to 1. And your domain in this case will be from negative pi over 2 to pi over 2. So switch around. And this is usually, that's the property, that is the definitions of inverse function for domain and range. They always switch things around here. So this is for sine function. And we're going to apply this for all the 6 trigonometric functions: sine, cosine, tangent, cotangent, secant, cosecant. But for this class, we only concentrate on sine, cosine, and tangent, because if you know this sine, cosine, and tangent, then the secant, cosecant, cotangent, you just need to do a little bit of reciprocal of it. So so we don't have to worry about graphing, not too much. So mostly is how do you, the definitions of the inverse function and what does that mean, okay? So let's talk about your cosine graph. So your cosine graph is the whole valley. And again, if you look, if you apply the horizontal line test, it fails because it crossed multiple times, not one time. So what do we need to do here is we have to domain restrict this below. So where do, like box, we draw the box like last time we do in sine. So where do we draw a box? So usually you'll notice that when you draw the box, you draw like a line without any turning points. And so what we do here is we draw a line that goes from here to here. So this is what we concentrate on, the red box that we draw. So the one that is not in the red box, we're gonna erase it. So we are doing this is because of once you erase everything from the graph of the cosine here, so it will pass the horizontal line test. So now the horizontal line will pass because it crossed one point. So what is the domain restrict in this case? It restrict from 0 to pi. So we restrict this from 0 to pi. So that means that the domain for this cosine graph, once you restrict it, is going to be from 0 to pi. And don't forget, it still take from -1 to 1. So your range in this case will be -1 to 1. So if you restrict this kind of to this domain, then your cosine graph will have what we call as the inverse function, and that will be the cosine of -1x. So same thing like what we do in sine. And what happens to the domain and range for this case is the flip of the original one. So the domain is the same as range, which is still -1, 1. And your range is the same as domain, which is from 0 to pi. So this is the cosine graph and the inverse cosine graph. So we do have to do domain restriction. And the last one we talk about here is tangent. So this is pretty important here, especially when you guys go to calculus class, when you talk about inverse function. And the first rule about inverse function in this case is make sure you know it passed the vertical and the horizontal line test. And if it doesn't pass it, make sure you have to apply the domain restriction. So you kind of erase the rest of it so that it will pass it. So for tangent, the graph for tangent is it has a vertical asymptote from pi over 2, -pi over 2, pi over 2. It looks like a cube graph. And then it goes again, repeat, right? It repeat and repeat. So you keep on repeat. Again, when you perform this, the horizontal line test, it fails. The reason why is because it passed 3 points here. So what do we do here is same thing. We apply the domain restriction here. So in this case, we only take one cycles of it. So for the tangent graph, we only take the first cycle, or the one that right in the y-axis here. So we will erase, we do not care about the rest of this, this tangent graph. So once you take all this off and you apply the horizontal line test, it passes because you only cross 1 point. So the domain in this case will be from -pi over 2 to pi over 2. So when we restrict the domain, now this is a little special here, is because we cannot use parentheses. And if you look at the sign, we use parentheses here is because we can include these two values. The reason why we cannot include these two values is because of the asymptotes, the vertical asymptotes that you have here. So, and the range that we have in this case will be all real numbers, because if you look at the line, it means it goes negative to positive infinity. So this is the function of the tangent graph if you domain restrict into just one cycle or one period. So what will happen is if you restrict this, then it will have an inverse function, and that inverse function is what we call as a tangent -1x. And the domain and range is being flipped. So that means your domain in this case is all real numbers, which is same as the range of the one. And your range in this case will be the same as the domain of the original function. In this case, it will be negative pi over 2 and pi over 2. So this is how we do your domain and range, the inverse function. So so we do have to domain restrict on all 6 of the trigonometric functions. So that will take care of what we're talking about here. So I'll return down here that we restrict the domain, so on, and this is your domain and range. I written down this as a inequality, but you can also written down as in the interval notation. So this is what we talk about. And just want to tell you that the notes here, the inverse function is not 1 over sine x. Okay, so this is not the same as 1 over sine x. Just same thing with 1 over cosine. Okay, we'll skip this graph first. So so there are some important informations here. Let's take a look at some of these examples. So this is very important. Okay, when we look at some examples. Anyone have any questions for me here?
So how do you know like where to put in the domain restriction box?
We just need to figure out where, when you erase it, so it will pass the horizontal line test. So for the sine, we will take negative pi over 2 to pi over 2. For the cosine, we take 0 to pi. And for the tangent, we take negative pi over pi. The reason why we take this is because it's close to the y, closer to the y value here, the y-axis. So we are taking that is because we don't want to take. You can also take for cosine. You can also take from pi over 2 to 3 pi over 2. But since it's not far, it's not closer to the y-axis, so we prefer not to take this part. So
okay, thank you.
So we want to close it to closer to the y-axis. So just to point out to you guys that so since we got positive and negative values, so this is 0 to pi over 2. So this is quadrant 1. So quadrant 1, everything is positive for sine. And then this is quadrant 4, because don't forget when you draw the backwards, quadrant 1 is on front, 2, 3, and 4. So quadrant 4 for tangent is negative. So you notice that when you do the inverse function, the positive fellow will go to quadrant 1 for sine, and the negative is in quadrant 4. And this is actually the negative 0 to negative pi over 2. So you go the backwards. For cosine, it's special because it take also 0 to pi over 2. This is also in quadrant 1, which is positive. And then from pi over 2 to pi, this is in quadrant 2. For cosine is negative. So we are doing 1 and 2 quadrant for cosine. 1 is positive, 2 is negative. And then for tangent, again, this is going up. So this is also quadrant 1. It goes from 0 to pi over 2. So it will be positive. So what we're trying to do here is we try to keep all this in quadrant 1, because we know quadrant 1, no matter it's sine, cosine, or tangent, they're all positive. But to make a negative for tangent for the inverse, we're going to take quadrant 4. So that will make him negative, and it will go from 0 to negative pi over 2. So this is kind of like fixed. Some of you were asking me, is this domain restriction is fixed between these two numbers? My answer to you is yes. We will always use this. So do your calculators. If your calculator is finding the inverse, so you can notice that your calculator have this -1 on top, right? That is the inverse function, and they only do either quadrant 1 if the value is positive, or quadrant 4 for sine if the value is negative. Same thing with cosine. 1 is positive, 2 is negative, and 1 and 4 for tangent. That means that when you do the inverse tangent for negative, you will get a negative angle between 0 to negative pi over 2. So this is pretty much fixed, and we don't change it. So let's talk about your examples here. So the first example that we have is what is the arcsine of 0? So sometimes I use the word arcsine, and sometimes I use sine -1. So these two are the same thing. So if you see in your homework or your test, I use sine minus to the power of -1, or I put arc sine. It means the same thing. So what is this means? It means that what is your x value when sine is 0? When sine is 0. So in this case, if you remember last time we did sine x equals to 0, this is what it means by that. Okay. So what we do here is, in order for us to do this again, we use a unit circle approach. So that means when you talk about sine, can someone tell me sine is your x or your y value in the unit circle approach? Sine is your y value. So this will be a y value. So so what you need to look at here is, what is the y value that we take form for? So if you look at this, which y value here give us 0? Yeah,
0 and pi.
0 and pi, or 0 and 180, right? So it's going to be between, so your answer in this case will be 0 or pi. But so now here comes the domain restriction that I mentioned about. So for sine, your domain restriction only goes from -pi/2 to pi/2. So which one of this is not a part of your answer? Which is your answer? 0? Is 0 in between this, or pi is between that? Which one is in between this? So pi is not between this. So your answer in this case will be just 0. Okay. So when you do this kind of questions, you have to watch out for the domain restriction that we're talking about here. So you use the unit circle to figure out first, and then after that, you have to erase one of the answer, because you get 2. Okay. Next one we have is arctangent of √3/3. Okay, so again, we look at your unit circles. Now, if you look at unit circles, they all have over 2, right? If you look at the one, they all have over 2. So what you do here is you just add over 2 to it. Can someone tell me tangent is what over what? X, Y. Anyone? Tangent is y over x, right? So looking at the unit circle, which one of this unit circle give us square of 3/2 as your y value? And 3/2. 3/2? No, we don't have 3/2. This one we need to change a little bit. We don't have a 3/2. We have 1/2. Is that what 3/3? Let me think about this one. This one might be so this one is 2. We don't have this fellow. What do we do in here? I'm thinking. So is this correct? I think this is correct. Yeah, this is correct. I need to think about this one. This is not working because of the 3/2, because we don't have a 3, we have a 1/2, right? We have 1/2. Let me think about this. Let's divide this. I think it's better. Yep, sorry. Let's do a division on this one, so it'd be better. So I'm gonna divide this up. The reason I divide this up, so you will see what's going. Yeah. So make sure you divide y over x here. So I'm going to use orange here. Yeah, I think I should divide y over x so you can see clearly which one is it. And the reason I'm dividing this up, because then you will see the tangent in this case. So if you take y over x, so if you take 1/2 divided by √3/2, I'm going to do this quick first. Then you will see. So 1/2 over by √3/2. So this will cancel out. So you get 1 over √3. and this will become root 3 over 3. So this is actually is this number. So when you divide y over x, you will get square root of 3 over 3. So the reason I'm doing this is because it's for tangent. So sorry. So what we're doing here is for doing tangent piece. And now we're gonna do the same thing for this one. So when you do y over x, this one is easy because both of them are the same. So you will get 1. So that means that tangent 45 degrees is 1, tangent 30 degrees is root 3 over 3. And I'm going to do the same thing on the next one over here, y over x. And the reason why I'm doing all this is because it will help you with your tangent. So if you do y, which is root 3 over 2, and you divide by 1/2, and the 2 and 2 will cancel. So what we left in this case is root 3. So this is actually square root of 3. So I am doing, and so this will be better for you guys, especially the one that I'm doing next to it, the y over x, is for tangent case. And if you want to go on to this side, it will be the same colors. That's why I use the black, blue, and orange. The only difference here is this fellow will be negative. This will be positive because when you divide both negative and positive, and this will be negative. So the only difference between the different quadrant is quadrant 2 will be negative, quadrant 3 is positive because tangent is positive in quadrant 3, and quadrant 4 will be negative. So 2 and 4 will be negative, 1 and 3 will be positive. So I'm doing that so it will help you with to do this kind of question that we have here. So now with this, you can figure out easily that the arctangent root 3 over 3 in this case will be pi over 6. Okay. And the reason why we do not want to take the 7 pi over 6, this below, is because 7 pi over 6 is not fall into the quadrant. Okay, so don't forget tangent only for tangent we only take negative pi over 2 to pi over 2. So the 7 pi over 6 is not in this. So another words is for sine and cosine, you only do quadrant 1 and quadrant 4. So when you do the arctangent or inverse tangent or inverse sine, you only take your angles from quadrant 1 and quadrant 4. And quadrant 4, we don't take these numbers, we do the negative, means that this will be negative pi over 6, this will be negative pi over 4, and this will be negative pi over 3. For cosine, if you do the inverse, we do the 1 and 2. So we will do this is positive, and then those are negative. And we will use back the same radian here for the quadrant 2. So the only quadrant 4, you go negative. Okay, just change this to negative pi 6, pi 4, and pi 3. So this is kind of the quickest way I can teach you how to read using the unit circle. This one, arc cosine of negative 1/2. So so this is your x. So this is your y, and this is y over x that you need to go. So for this case, you need to look at your unit circle, and because it is cosine, so cosine only do quadrant 1 and quadrant 2. So you do not need to look at quadrant 3 and 4. So which one of this will give us negative 1/2 on the x value? So x value.
Wait, what are the only quadrants that I can be in?
Cosine is only do 1 and 2. Tangent and sine is 1 and 4. It's based on the domain restriction that we have early on. So in this case, the number for what is the inverse cosine of negative 1/2? Your answer in this case will be 2 pi over 3. Should I give you more?
Yes.
Yes, this is something also I will ask in your test, and in the test you are not allowed to use a calculator. So I'm going to give you more. So this is again, you have to use a unit circle. So what is the inverse sign of negative 1/2? Again, sign is for quadrant what? Quadrant 1 and quadrant 4. 1 is positive, 4 is negative. So what is the arc sign of negative 1/2? And sign is your x or y value. Sign will be the y value. So can someone tell me what will be your answer in this case?
11 pi over 6.
Unfortunately, 11 pi over 6 is wrong because it has to be negative. So your answer will be negative pi over 6. So instead of going clockwise, you go counterclockwise. And the reason why I'm saying this out is because if you remember what let me save this first so that you can. It's all based on the domain restriction that we mentioned early on. So if you remember the domain restriction for this, see, quadrant 1 is positive, quadrant 4, your number is 0 to negative pi over 2. See that? And then same thing with tangent, it is also from 0 to negative pi over 2. So that's the reason why that when you look at this value that I'm telling you here, you cannot take 11 pi over 6 because it's a positive. So you have to go clockwise. So that will be negative pi over 6 in this case. If it's go here, this will be negative pi over 4. This will be negative pi over 3. So if you go clockwise, you just change all this to become negative 1 pi, 6 and 4 and 3. You guys with me here? Tough? Yeah, I didn't say it's easy. Let's do a cosine first. What is the arc cosine of negative root 3 over 2? So that's the reason why I really want you guys to use a unit circle here. So can someone tell me arc cosine, what quadrant it goes to, 1 or 2? 3 or 4? Which one?
1 and 2.
1 and 2. But to be more specifically, 1 or 2?
1?
This value is negative or
Oh,
positive?
2.
So it'll be 2. So 1 can only take when the value is positive, right? So now we just concentrate on quadrant 2, which is this fellow. Which one is, what angle give us the x, right? Cosine is x, is negative root 3 over 2. What's your answer here? That will be 5 pi over 6 because that's your x value, square of 3 over 2. So your answer will be 5 pi over 6 here. You guys all right?
Okay, so for sine, it's y over x and tangent y over x, but for
No,
cosine,
sine
it's
is
x over
y. Sine is just y. Sine is y. Cosine is x. Tangent is y over x. This is the sine is a y value. And cosine is your x value in the coordinates. And the tangent is y over x values. Yep. Again, this is fixed. You cannot, this is fixed. Cannot do anything. Oops, sorry. All right, one more. What is the arctangent, which is same as the inverse tangent of -1? So can someone tell me what quadrant should this belongs to? 1, 2, 3, 4.
Would it be 4?
Yep, you're correct, because it should be either 1 and 4, but since it's a negative, so 4 is correct. So now we just concentrate on quadrant 4 in your unit circle, which is this fellow. Can you tell me which one of these will give us -1 when you divide it?
7 pi over 4.
And again, we cannot use 7 pi over 4. It's correct. The reason why is because it has to be in negative. So your answer should be what? So going counterclockwise, what is a clockwise of 7 pi over 4? The negative value. Anyone?
Would it be pi over 4?
Negative pi over 4. And don't forget, pi over 4 is up here, negative pi over 4 goes down. So this is your answer in this case. Yep. So make sure you guys know how to, this is again, is there any practice on this? Yes. Where can you find the practice? If you go all the way down to the homework 6.6, the first few questions you see in your textbook, 5 till 10 or something else, is where you begin to do your, they have all these questions that you have, the one that I'm showing you here. So make sure you practice on it, okay? Also in your homework. Okay, so try your best. If the question says do not use any calculator, please don't use your calculator. Otherwise, you defeat the purpose of doing it. 4, 5, 6 you have, then you can use your calculator here. So take out your calculator and do this. Now, first thing first is make sure when you do this kind of question, make sure your mode is in radian. You guys know how to change your calculator mode to radian, right? Because we don't use degree anymore. So in order for you to do question 4, 5, 6, make sure that this is calculator. Make sure you change your mode to radian first. So a lot of students ask me in the homework why I get this wrong. That's my first thing is, do you change your mode to radian or do you use degree? If you use degree, yep, you get it wrong. So, and then you do the arc sign. So for question 4, you just type the arc sign, which is the x sign -1, and then you put in -0.75. Go ahead and use your calculator, and they want it in two decimal places. So calculator, on my calculator. I need to use not the standard one. Should not. Nope. Shall I? Cannot do standard here. I need to use a scientific. So arc sign. So you have to do the shift. Some of you, mostly all your calculator have a shift, and then you have to do the sign. So for my case, a little bit different. I need to type the 0.75 with a negative first, and then you second shift, and then the sign came up. So your answer, oh, sorry, this is in degree. So that's the reason why I know it's wrong, because this is a degree. Your radian is usually like very small, like 1 point something. So I can, so this is why I say it's wrong again. I'm going to retype it again. Okay. So make sure you guys don't do this mistake that I just did here. Let's do this second shift sign. So it's going to be -0.85. You guys got this? You guys good?
Yep.
The rest, I think you guys can go and try to do it. This is just, you know, go ahead and go home and try to do this. Is, you know, use your calculator and punch. Make sure the only thing I worry about, make sure your mode is in radian. That's what I want to tell you. Okay. So make sure you go home and try to do the rest of 5 and 6, because pretty much straightforward type questions, and make sure you know how to round, which I think you guys know. 7 is the one that I want you guys to pay attention here. So 7 is giving us that this is your theta, this is 10, and this is x plus 1. And question 7 is asking us to find what is the inverse trigonometric function in terms of x. So what do we do in this case is you have to use your SOHCAHTOA. So every time when you guys see a right triangle, SOHCAHTOA is what we apply here. So can someone tell me what is this? Is that opposite, adjacent, hypotenuse? What is this called? What's the 10 called? if this is your theta here. Opposite, adjacent, hypotenuse,
Adjacent.
and x plus 1 is what?
Opposite.
So what use opposite and adjacent? Sine, cosine, or tangent?
Tangent.
So this is going to be tangent theta equals to what over what? Opposite over adjacent, right? X plus 1 over 10, right? This over this. So what is going on in this case is this question doesn't want us to write tangent theta. This question wants us to write theta. So what do we do here is we have to move the tangent over. So like x squared. And how do we get rid of x squared? What we perform is we square it. We take the inverse of it, right? So what we do is when you move over here, the tangent will become the inverse. So become arctangent of x plus 1 over 10. So your answer in this case will be to write this in terms of theta, it's going to be arctan of x plus 1 over 10. So this is not difficult. This is what you guys learned in previous homework 6.2, I believe, using SOHCAHTOA. But what you do here is instead of using tangent theta or sine theta or cosine theta, you just move the sine, cosine, and tangent over to the other side. And once you move it, it becomes the inverse tangent of it. This is the definition of inverse tangent. You just, so when you guys solve an equation, you if you're going to get the tangent to the other side, make sure you put a arc on it, the inverse tangent of it. You guys all right here? We'll come back with 8 and 9 on Monday. So we're going to do 10 a little bit. So 10 is the same thing. Okay. So you have to find the exact value on this expression and sketch a right triangle. So usually the hint is calling you to draw a right triangle. So how do we do question 10? Is using sine arctan of 3/4. So what we do here is, sorry about bad handwriting. So we're gonna let this whole thing to become theta. Okay, so let theta to become the arctangent of 3/4. So when you let this, so this is just turn out to become sine theta. Okay, because this whole thing turned out to be theta. So as usual, if you move the tangent over there, it becomes the inverse tangent. So what happens when you move the tangent back over here? The inverse tangent. So that will become tangent. So now this is where you begin to draw your right triangle. And we know this is a theta. So can someone tell me where do you put 3 and where do we put 4 in this?
3 is on the opposite side, so and 4 is on the adjacent.
Can someone tell me what is your hypotenuse? If you know your triplets, 3, 4, and what's your triplets? 3, 4, and anyway, your triplets. This is important. Otherwise, you'll use a Pythagorean theorem to figure out this. 3, 4, and 5. Forget triplets 3, 4, 5. So can you tell me what is your sine theta here using your triangle? Sine is what over what? Opposite over by what? Hypotenuse. So what is your sine theta in this case? It will be 3 over 5. So what is this answer? Your answer will be 3/5. So what is going on in this kind of questions, 10, 11, 12, is you have to actually use, you have to move the tangent or whatever you have to backwards, and then you have to draw a right triangle to use your SOHCAHTOA to apply it. So we're going to do the last one, 11 in this case. Cosecant, do a little bit here. cosecant of the arctan negative 512. Okay. So again, we're gonna let this to become theta. And we're gonna move the tangent back to arctangent to backwards, so it becomes tangent theta. So can someone tell me, oh, this one, we have to use quadrant 4. This one is quadrant 1 because it's positive. So quadrant 4, the triangle looks something like this. Don't forget, if you want to know what kind of triangle looks like, you draw a ribbon. So quadrant 1, this is what it looks like in quadrant 1. Quadrant 2 looks something like this. Quadrant 4 is the one that it goes downwards. So by looking at this tangent theta equals to negative 512, what should we put for here? Anyone? Opposite is what? Negative 5. And your adjacent is 12. So can someone tell me what is your hypotenuse? Is another triplets? 5, 12, anyone? And this will become what? 13. Those are all your triplets. So now what we have in this case is cosecant theta. Now, can someone tell me what is sine theta that we did last time? Sine theta is opposite over hypotenuse, right? So what will be cosecant will be? Flip it. So it's hypotenuse over by opposite. And your answer in this case is hypotenuse is 13. And your opposite is negative 5. So this cosecant arctangent of negative 512 is 13 over negative 5. This is your answer. So so for question 10 and 11 and 12, make sure you do this kind of work that I'm showing you here. Also make sure you know what kind of triangles that you draw. If you draw the wrong triangles, then your negative will be in the wrong direction. Okay, so make sure you guys know where you put your negative at. So once you come back on Monday, we will talk about 8, 9. I know we skipped 8, 9, and then we'll talk about the 13 and 14. So this is the last piece that we will do here, and then we'll probably do a little bit of work. We can skip the graphing, so don't worry much about graphing. I'm not going to test you how to graph this. So I'm more testing you about what we did early on in the first 3 questions in your test. So make sure, and the one that we did right now, this kind of questions, 10 and 11. So make sure you guys know how to do this. So I'm going to end today's Zoom session here. So make sure if you guys have any questions, please ask me because I have to get going here soon. Your homework for tonight, don't forget you get homework for today, is going to be 6.4 due tonight, and then 6.5 and 6.6 due on Wednesday. Okay, next Wednesday, not the next week. So I'm going to stop sharing and start recording here. I think you guys take your attendance ready, right? So anyone here needs and have any